All right, guys, this is cycle 2. We're going to talk about just some measures of some data. So we have a data set, and there are certain things that we can find within that data set. And this should be a really quick review, so I'm not going to spend a lot of time on it. So if you don't understand a certain part of this, maybe pause it, rewind it, listen to it again. If you still don't understand, then ask me in class, and we can go over some more examples. So for this data set, to understand what mean, median, mode, range, IQR, and outliers is, we're going to use the following data set. So I want you to write this down on your paper. So we're going to use the numbers 1, 1, 1, 3, 4, 5, and 20. So we're going to use that data set to go over all 6 of these kind of measures when you have a data. So let's get started. So for mean, when we put for what is mean? It's the average. And how to find it? You add, then divide. So here's our example. If we add all of the numbers in our data set, we get 35. And then we divide by how many numbers there are. And so we have 1, 2, 3, 4, 5, 6, 7 numbers in our data set. So 35 divided by 7 gives us 5, and so 5 is our mean. For median, like if you think you're driving down the highway and you can drive this way and you can drive this way, and then there's this grass in between, that is the median because it is the middle number. So for how, we want to make sure your data is in order, and then you find the middle number. It's really important that your data is in order. If your data is not in order, then you're going to find the middle number, but that's not going to be the median of your data. So make sure your data is in order from least to greatest. So let's do this example again. So 1, 1, 1, 3, 4, 5, and 20. I have 7 numbers, so I'm going to cross 1 on each side, and it leaves me with a perfect number right here in the middle. And so my median, the middle number is 3. All right, IQR is your interquartile range, inner quartile range. And that is Q3 minus Q1. It's the width of the box. So if I had a box and whisker plot and I had this data 1, 1, 1, 3, 4, 5, and 20, and I found the median, which we said was 3, and then I wanted to find the median, the quartile 1 is the median of my first half, quartile 2 is the median of my second half. So this is my box, and these become my whiskers. So the inner quartile range is this length. So from 5 to 1. So my quartile 3 is 5. My quartile 1 is 1. So to find the inner quartile range, it's 5 minus 1, so 4. So inner quartile range is the length or the width of the box when you make a box and whisker plot. And so you take the third quartile, which is the median of the second half, and the first quartile, which is the median of the first half, and you subtract them, and that's your inner quartile range. Mode is the number that occurs most often. So I always think of mode and most. So we have mode is the most often. So how? You just find the number. that is listed the most. It's not the highest number, it's the one that's listed the most. So if I have our data set 1, 1, 1, 3, 4, 5, and 20, the number 1 is listed 3 times and it's the most listed number. So that means that our mode is 1. All right, the last thing that we have is range. So range is the distance between the highest number and lowest number. So how do we find it? We just take the highest number minus the lowest number. So in our example, let's write our numbers back out. So we have 1, 1, 1, 3, 5, 3, 4, 5, 20. And we want to take the range. So we want our highest number, which is 20. And we're going to subtract our lowest number, which is 1. So we have 20 minus 1 equals 19. So 19 is our range. All right, and outliers, I think a lot of you know what an outlier is, and there's a mathematical way that you can definitely find an outlier, or we know for sure if a number is an outlier. There's a mathematical way you can do that. I'm not really concerned with can you mathematically find it. I just want you to understand what it is. And so an outlier, and this is kind of hard to put into words without making it too wordy, but I'm just going to say that it's data that is, let's say, far away from the rest of the data. I think that you guys understand what I mean when I word it that way. And so you're kind of looking for a number that's like the odd one out. So I made it pretty obvious in this data set. So if we have the numbers 1, 1, 1, 3, 4, 5, and 20, obviously 20 is our outlier. So that number is far away from the rest of the data. If I were going to draw a number line and I had numbers 1 to 20, and I did like a dot plot, I would have a dot way down here, and then the rest of my data would be way over here. And so we have this whole gap right here that shows us that we have an outlier. It's just a value or multiple values that are pretty far away from the rest of the data. So hopefully you guys understand those 6 kind of measures that you can find when you're given a data set. The next thing we're going to talk about, and this again is pretty easy, it's just 3 fill in the blanks. We're talking about the shape. This is the shape of data. So if you plot data on a histogram or a dot plot or a box plot, you should be able to look at it and say, okay, that's symmetric, or it's right skewed, or it's left skewed. And so it's not tricky, but it's a little opposite of what you might think. Symmetric is pretty easy to look at. You should be able to look at data or a bar graph, a histogram, a dot plot or a box plot and say, okay, if I draw a line down the middle, it's going to look symmetrical on both sides. So remember, symmetric means that it's the same, it's like a mirror image. So if I draw a line down the middle here or down the middle here, then the left and the right look like mirror images. And so this is called symmetric. Okay, so it's symmetric, it's bell-shaped. When you have data that's really, really heavy on the left and there's not a lot of data towards the right, then that is called skewed right or positive. So it's right skewed. So where there's not a lot of data on the right, so it kind of goes down to the right, down to the right, it goes down to the right, it's right skewed. So if we go down to the right, then it's right skewed or it's positive skewed. If we look at data and it's down to the left, down to the left, down to the left, then it's left skewed or negatively skewed. So this is where fewer data plots are found to the left of the graph toward the smaller numeric values. So the tail of the graph is pulled towards the lower or negative values. So most of the data is to the right, but it's called left skewed. So I always kind of think of where the tail is or where we go down. So if we go down to the left, it's left skewed. If we go down to the right, it's right skewed. If it looks pretty even on both sides, it doesn't have to be exactly even, but if it's pretty even on both sides, then it's called symmetric. So maybe rewind this section, just kind of re-listen to it. Again, I just want you to be able to look at a data display and be able to look at it and say, okay, that's pretty symmetric, or maybe that's right skewed, or it's left skewed. So you should just be able to describe it using one of these three terms. Okay, so those are your guided notes for this cycle. Let me know if you have any questions. See you in class.